Hello.
Yeah. Hi, Shana. How are you?
Hi. Good. How are you?
I'm doing good. Thank you. Okay.
So
So, what do we have to discuss today, Shana?
last week we did the 2018 Cayley contest. So today we can do the 2017 one.
2017. Okay. 2017. Okay.
And
So,
this,
23, 24, 25 wrong.
yeah, I didn't understand this one.
Okay. Um. Okay, we haven't discussed this before. All right. Okay. I hope you're able to see the screen. So, it is from the 2017 Cayley contest, question number 23. The triangle with sides 6, 8, and 10 is right angle, while the triangle with side lengths 6, 8, and 9 is an acute triangle. The triangle with sides 6, 8, and 11 is an obtuse triangle. An obtuse triangle with positive area has side lengths 10, 17, and x. If x is an integer, what is the sum of all possible values of x?
Yeah.
Let me draw this and check. So they're saying that it is right angled at 6, 8, 10. Maybe like this is the lengthiest one. So this will be a 10. So you might be having the triangle like that, like 6, 8, 10. And while the triangle with side length 6, 8, 9 is an acute triangle. So acute means okay. Maybe like 6, 8, and 9 you can say. And for obtuse, it is 6, 8, 11. So it might look like this for the obtuse one. So it is supposed to be 6, 8, and 11. Obtuse triangle with positive area has side lengths 10, 17, and x. Okay. So it might. So let's consider this as the obtuse. We're not sure which one is 10, 17, x. I'm just randomly substituting 10, 17, and x. Okay. So now you need to find the value of x. And after finding the value of x, you need to sum all the possible values of x. Okay.
Yeah.
So So for solving this problem, we are going into a concept called triangle inequality. And do you have any idea about triangle inequality?
Yeah, so like any two sides of a triangle, if you add them together, it has to be bigger than the third side.
Third side. Okay. Maybe like we can say A plus B has to be greater than C. If you put A plus C, it has to be greater than B. If you put B plus C, it has to be greater than A. Right? So the sum of lengths of any two sides of a triangle is greater than the length of the third side. So that is triangle inequality theorem.
Yeah.
Okay. All right. So they're saying that we need to use two facts about triangle with positive area on the side lengths. So A is lesser than or equal to B, B is lesser than or equal to C. So we know that A plus B is greater than C, which means the sum of the length of any two sides of a triangle is greater than the length of the third side, which is C. So, and based on the fact that the shortest distance between the 2 points is a straight line. In this case, the shortest distance between the two vertices of a triangle at opposite ends of the side with length C is the length C. Any other path between these paths is longer. In particular, traveling between these 2 points along the two other sides is longer. For example, let's assume this is A. So C. The shortest distance between any two vertices of a triangle at opposite ends of the side with the length C is the length C. Any other path between these spots is longer, which means like if you add the red and purple path together, that is going to be definitely greater than the green path.
Yeah.
So this path has the length A plus B, and so A plus B is greater than C. So this is just a triangle inequality theorem.
Yeah.
And in our question, they specifically told us to use the obtuse triangle. Right. In the obtuse triangle looks like this. Let's do a rough one. Then A square plus B square is lesser than C square. If the triangle is acute, A square plus B square is greater than C square.
Yeah.
So this makes sense from the given examples. The fact that A square plus B square is equal to C square. Then the triangle is a right angle triangle. You know Pythagoras, right?
Yeah. So we know now that x must be less than 27.
Yes.
And we also know that x must be less greater than 10 squared plus 17 squared.
Yes. So in the first inequality, they are saying that x is lesser than 27. Since x is an integer, then x is lesser than or equal to 26. If you apply the second inequality theorem, you can say x square is greater than 389. What does it mean? It means you're supposed to square it. So you'll be having 389. So x square is greater than 389. For finding the value of x, you just have to take square root both the sides. So we're going to have 389. So if you take the square root approximately, you might be having 19.7. Okay, do you know how to take square root for 389?
I use calculators.
Without calculator?
Um, Well, I know that you can find like in between what numbers it can be. So we know that 19 squared, or I mean 20 squared is 400. So
Yeah. Okay.
then,
Shall I teach you the method of finding the square root?
okay.
For example, okay, I'll just take the same 389 itself. Okay. So for finding the square root of 389, I'm going to pair the 0, 389 into 0, 3 and 89. I'm just dividing them into two groups, and also I need a pair. Okay, but I do have 389. I do have only three number. So to make this
Yeah.
as even, I'm including 0 before. So that is step 1. You just have to keep it in the form of even, and then you have to group them into pairs. Okay, that is step 2. And
Okay.
now, you know the square table, right? You have to check the value which is lesser than this. Okay, if you multiply 1 by 1, you're going to get 1. So that is lesser than 3. If you check the next number, which is 2 into 2, 4, the 4 is greater than the 3. So you're going to choose the lesser value. So I'm going to place 1 over here and here as well. So 1 multiplied by 1 will give me 1. So this might seem like a division. So 3 minus 1 will give you 2. Okay. So now I'm going to bring this pair down. This is my next step. Here, whatever you are getting, you just have to multiply this by 2. That is step 2. Okay, remember? You just have to multiply this by number 2. So when you
Yeah.
double this, it becomes 2. So now it's purely trial and error. So now you're going to keep the next decimal. So that has to be, you're going to put some value here. The same value, you have to place it in the place of quotient as well. For example, if I put 1, 1, I have to take this 1 and multiply with this. Okay. So 1 into 21 becomes 21. This is very smaller. So I have to put some value which is very closer to this. As you said, you'll be doing this in the form of a trial and error. You can just predict the approximate value. So if you try 9, 9 times of 20, 9.
That's
What is 9 into
100.
20?
That's 261.
It's 261. Okay, so it's 261. So when you subtract them, you're going to have 18. Right? So from this, it is clear the integer value is 19. And
Yeah.
further, you are going to add, proceeding further, you're just going to add a pair of zeros just to include them. So again, you're going to continue this. So again, you're going to double the latest value. So this is 9, it becomes 18. So 18 means 8, and you'll keep 1 here. This becomes 3, 8. So again, you're going to keep a value over here and here as well. So you can try with 7. So it's going to be, okay. Since you have included 2 zeros, you're going to keep a decimal point over here. This is very
Yeah.
important. You have to keep a decimal point. So it's going to
Okay.
be 7 into 387. Could you please tell me what is 387 into 7?
It's 2709.
270, then it is exceeding. I think it's supposed to be 28 here, right? Yeah, it's supposed to be 2709. Actually, I put 18 before, it was actually 20.
Okay.
So this is how we will proceed. Actually, for this problem, you can give some approximate value But if you are in need of some exact values, like you need to find up to like 2 digits or 3 digits after the decimal point, then you can use this method. All you have to do is just you have to multiply the divisor by 2. You just have to double the divisor, the latest divisor by 2. And for the next decimal should be same as your quotient. That you have to keep it in mind. And you'll be multiplying the divisor, the whole divisor and the quotient, the latest quotient value. Can you follow
Yeah.
this? So
Yeah,
by
I
doing
get it.
this method, you might be able to find the value of the square root. I mean, this is for the not perfect square, the imperfect one. Okay. So this is how you will obtain 19.7. So x is an integer, so you can round it off. You can round off this to 20. So you might be having a problem like, like rounding off. At least you need to know what comes after the decimal. Because if it is greater than 5, you will round off to the next digit. Otherwise, like you will round off to, the previous one. So at least try to figure out the very first decimal after, the very first digit after the decimal. Okay. So here you are obtaining the value as 20. It is greater than 20. So and also we know it should be lesser than 27, right? It is greater than or equal to 20 and it is lesser than 27. So these are the possible values: 20, 21, 22, 23, 24, 25, and 26. Can you follow this, Shana?
Yeah. So now we just have to add those.
I think we are not done yet.
Okay.
Actually, according to this, like a square plus b square is lesser than c square, right? So
Yeah.
according to that, we did like 10 square plus 17 square is lesser than x square.
Yeah.
What if you have, a as 10 and c as 17? There is a chance for that also. Can you follow?
Oh yeah. Yeah, I get it.
Because you do have like, in the right angle, you do have adjacent side, hypotenuse, and the opposite side. We
Yeah,
don't know
that
which
makes
one fits which one, right? For that purpose, you're solving it for 10 square plus x square lesser than 17 square as well.
yeah,
Can you
okay.
follow?
Yeah, that makes sense.
Yes? All right. So according to this, if you solve this inequality, you have x plus 10 greater than 17.
So now you can
So you just have to subtract both the side, 10, right?
yeah. So you get x is greater than 7,
Yeah.
or x is greater than or equal to 6.
Yes. Greater than or equal to 8.
Oh yeah, greater than or equal to 8. And then for the second one, it would be x squared plus 10 squared is less than or equal to 17 squared. So then we would get x squared is less than or equal to 189.
289 minus 100, which will give you 189. So if you take
Yeah,
square root for this, you're going to have, okay, well, can you try the method I taught you for this 13.75? Can you just try whether you're obtaining the same result for 189?
okay.
Yeah.
So I forget how we like start, like what the chart is going to be like. So it's like this, and then you have 0, 1, 8, 9, and we know that one squared is 1 and 2 squared is 4, so we would put the lesser one. So there would be 1 here, and then we subtract 1 and we get 0. So would we put 0 in the top or 1 in the top? Like
Yeah.
what? Okay, so
Yeah.
put 1.
That's okay. You can just ignore the 1. You can bring the 89 and you can solve it.
Yeah, and then I bring the 89. And now I have 2 here. And then you'd find a number to put here and here. So the closest one would be if you put 3, then you get 3 times 23, which is 69. So then we get, but if we put 4, then it's going to be like 90 something. So closest is 3. So then we subtract 69 and we get 20. And then you have to put a decimal point, and then you add 2 zeros here. And then you have 30, 36, would it be? Is that right?
2030. Yes, yes, yes.
Okay, and then we have to find a number that.
1 minute. You do have 23 here, right?
Yes.
It's just 26. That's it.
Oh, 26? Okay.
Yes. You don't have to increase its value by 1. Maybe if you're having like 28 or something, when you double this, you're going to have 16, right? So that time you can increase its value by 1.
Oh, okay.
Can you
That's
follow?
why.
Yeah.
Yes. Okay. So then it'd just be 26.
26.
So
yes.
we have to
So
add
you
like
have
a
to
digit.
put another digit.
Yeah. And then so 260, maybe 267 times 7 is, that's 1,869. And 268 times 8 is 2,144. So that's too much. So it would be 7 here. And then we subtract 267 times 7. Wait, what? 267 times 7 is 1,869. And then we subtract 2,000 from that. And we get 131. Now we can add 2 more zeros. And then we double it this time. We double 6 and you get 12. Wait, do we double 267? Or just 26? Okay, so then it would be 4. And then 7. Then 2. So now we have to find if it fits. 2745 times 5 is 13,725. So that doesn't work. So then 2, 4, 7, 5. 4 times 4 is 900 and 890. So we would get 4 here. So then it'd be 13.74. But I think the next digit, it would be more than 5.
Yeah, they might
So
be
then,
rounded off to 13.7.
and
Yes,
then they rounded it.
absolutely. But you can go with the 13.7 itself, right?
Yeah.
Okay.
I mean, it doesn't really matter because we can only have whole numbers, so we have to change it to
Yeah,
this.
yeah. The lesser value, right? So it's going to be like 8, 9, 10, 11, 12, 13.
So then x is less than 13. So then the possible values are 8 to 13. And then we get all together, we have 8 to 13,
8,
then
9,
20.
10, 11, 12, 13. You just have to sum up all these possible values. If you do that, you're going to get the
Yeah,
answer is 224.
exactly.
That's nice. It's an interesting question, but definitely it would be boring to do it alone.
Yeah.
Okay, we also done some checking.
I think
This
sometimes
part
at
is
the end,
not required.
yeah, they just do that to just check, and like since they're explaining to us, they're just adding
Yeah.
extra.
All right.
Yeah, this question was interesting.
Yes.
Okay, so
The
three
next
coins.
question. Yeah. Yes,
Three
yes,
coins.
please go ahead.
3 coins are placed in the first for the first 3 of 6 squares as shown. A move consists of moving one coin one space to the right, assuming that this space is empty. No coin can jump over another coin, so the order of coins will never change. How many different sequences of moves can be used to move the last 3 coins from the first 3 squares to the last 3 squares?
How many different sequence of moves can be used to move the 3 coins from the first 3 squares to the last 3 square? Okay. But you can only move to right.
Yeah,
It has to be XYZ, 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 right?
exactly. And so I think they're trying to say, like, how many ways can you do that? So I guess you could move the Z all the way to the other end, and then the Y all the way, and then the X all the way. Or you can move Z once, Y once, X once, then Z once, Y once, X once. So we just have to find how many different ways there are to move.
Yes, yes, yes. Okay. Okay. We think each allowable sequence of moves as a string X, Y's, Z's. For example, the string Z, Z, Y, X, Z would represent moving Z one space to the right. Z, Z, Y, X, Z. 1 minute. Let me draw it. You do have 6. Okay. Okay. So you already have X, Y, Z here. So when you move Z to the right, you have moved Z to the right. So you will write Z. Okay. So again, you're moving Z further to this box. You're going to have Z again. Okay. So now this is empty and you have Z here. And now you are trying to move Y to this space. So you
Yeah.
have written Y here. So Y occupies the third box. So now you will move X here. You have X. Okay. So again, they represent Z. Meaning is you're moving this to right again, right? So you're gonna have Z there. All right. Okay. There might be another possible strings as well. We don't have to, precisely look at this one. It can be
Yeah.
like XY space Z also. It can be XYZ also.
Yeah.
It doesn't have to be always this one. Okay. So now you do have XYZ. You're assuming this is an integer. So X is varies from 0 to 3. Similarly, Y varies from 0 to 3. Z varies from 0 to 3. Here, this X, Y, Z is nothing but the number of sequences of moves, which results in X moving X spaces to the right, Y moving, capital Y moving Y spaces to the right, Z moving Z spaces to the right, which means you can try to push to the end also. To the maximum, you can go up to 3 moves. 1, 2, 3, right?
Yeah.
Let's assume the Z is here now. Okay, we have pushed to the limits. So now the Y. Y can also move 1, 2, 3. It can't go beyond that because in the question they have mentioned that it can't jump over another move, right? So to the maximum it can move here. And for X, so let's assume a situation Y and Z are there. So X will move here, 2 and 3. So it only varies from 0 to 3 moves. Can you follow this? Okay.
Yeah.
So you are just using S of 1 comma 0 comma 0 in the sense X comma Y comma Z, which means X just moved one space further. There is no movement for Y and Z. Can you follow?
Yeah.
So in this case, it doesn't happen, right? Because for the movement of X, at least Y and Z have to move.
Yeah.
They have to move, right? So you can't move X until you have Y and Z in front. So that is not possible. 1 comma 0 comma 0 is not possible, right?
Yeah.
And if you try to move Y alone without moving a Z also, it is not possible, right? So 0 comma 1 comma 0 is also not possible, which is why you have 0 here. So since X and Y are not allowable sequences, we can say Z is allowable, right?
Yeah.
You can move Z. So you can write this as 0 comma 0 comma 1. You have moved one space further, so you can put 1 here. Maybe like probability of the movement. Since Z is allowable and is only sequence of one move. All right. We want to find S of 3 comma 3 comma 3 for all the 3 values of X, Y, Z.
Yeah.
And from this it is clear X is greater than, okay, if X is greater than Y or Y is greater than Z or X is greater than Z, X comma Y comma Z is 0 because this will not happen, right?
Yeah.
You can't move like 2 steps for X and 1 step for Y. That will not happen. For
Yeah.
moving X to 1 step, at least you have to move Y for 2 further steps, right? So this is not possible. So for this condition, you are saying that X of X comma Y comma Z is 0. So this, since any allowable sequence has to have at least as many Z's as Y's and at least as many Y's as X's. Because no
Yeah.
coin can jump another coin. Okay, this we already knew. They're saying that X is lesser than or equal to 0. and x is lesser than or equal to y, and y is lesser than or equal to z, and z is lesser than or equal to 3. We can write the condition in this way.
Yeah.
All right. All right. So s of x comma y comma z is equal to s of x minus 1 comma y comma z, s of x comma y minus 1 comma z, s of x minus x comma y comma z minus 1. For example, if you substitute the value of x as 0, then we can say it will be negative 1 comma y comma z. So then you will have 0. If you substitute y as 0 in this, again the probability is 0. If you substitute z as 0 also, again it will be 0 only. The negative is not possible.
Yeah.
All right. Okay, so we are coming to few conclusions here. Every allowable sequence counted by s of x comma y comma z ends with capital X, capital Y, or capital Z. It can't go beyond that. If an allowable sequence counted by s of x comma y comma z ends in x, then the sequence formed by removing this x was allowable and is counted by s of x minus 1 comma y comma z. Which means it's just 0. The s of x comma x minus 1 comma y comma z is 0.
Yeah.
And you can also write it in this way. X minus 1 lesser than or equal to y, lesser than or equal to z. Okay. Meaning is x minus 1 x's, y y's, and z z's. And making s of x minus 1 comma y comma z greater than 0. And x is lesser than or equal to y, y is lesser than or equal to z. Then every sequence counted by this can have capital X put on the end to make the sequence counted by s of x comma y comma z ending in x. Okay, I think this we can only substitute the values and check. We can come to the conclusion after checking them. We'll just substitute few values and see. For this rule, we'll go to the table of values and see. So you are going to substitute 0, 1, 2, 3 and 0, 1, 2, 3.
The meeting's gonna end in a minute.
Oh my God. I think it will take another 3 more minutes to join again, I guess. Please go through the table till then. Okay, in case if the meeting ends, I will organize it. All right. So you have x is 0, y is 0, and z is 1. Is there any chance like this? 0, 0, 1? Yes, right?
Yeah.
Which means you can't move x and y, but still you can move z one step further. Yes, that is a possibility. So you can put 1 here. And you have 1, 0, 1. Y is not moving. Y is not moving means definitely you cannot move x also. Right?
Yeah.
But still you can move z to the next space. But for x, it is not allowed. You're going to put 0 here. Can you follow this?
I'm kind of confused about the table. So like.
Okay, this table I'll teach you. Could you connect in the WhatsApp if possible for 4 minutes?
Okay.
All right.